Good afternoon to one and all. Can you able to hear my voice? So, I'm not able to turn on my video today due to some internet issues. So, is my voice and my screen audible and visible to all of you? Yes. Okay, okay. Thank you, Pratyusha. Thank you. So, students, yesterday we have started solutions lesson. Okay. So, let's continue with that today. Got it. So before moving on to the today's topic, I would just want to recall the yesterday's topics. Okay, I'm going to give you a recall test. So in this, I'm going to ask three questions to you guys, and you are going to give me the answer in the chat box. Okay. So the first question is, give an example for gas and solid type of solution. Give an example for gas in solid type of solution. Yesterday we have discussed the classification of solutions, right? So in that we have discussed some 9 types. So one among that is this, and you have to give me the example for this type. Give an example for gas in solid type of solution. Adsorption of H2 by platinum or nickel. Very good and very good. Good. You have done a great job. So moving on to the second question. What is mass percentage? What is mass percentage? So mass percentage is one of the concentration term. So what is the formula for mass percentage, or what is the definition for mass percentage we have studied yesterday? What is the formula? Give a try, give a try. What is mass percentage, students? Mass of solute divided by mass of solution into 100. Okay, very good, Ritika. So we have left that 100, I think, but I think it is due to some difficulty in typing. Okay, I understood that. Good. So Ritika has given the correct answer. Very good. By total mass into 100. Aljo, good. Great. So moving on to the third question. Give the formula for mole fraction. Give the formula for mole fraction. Give the formula for mole fraction. Yeah, good afternoon, JNV Badnagar students. Good afternoon. You have joined little late, it seems. Huh? But anyway, no issues. Okay, so try to join on time from tomorrow onwards. Okay, what is the formula for mole fraction, students? Mole fraction is denoted by the letter X, and what is the formula? So if I want to find out the mole fraction of the first component or the mole fraction of the component A, what I have to do? So one of you have given the answer. Na by Na plus Nb. Very good, Abhijit. Very good. Very good, Ajo. Very good. Na by Nb plus Na. Very good. Good students. So now let's move on to the today's session. So as we have studied yesterday, the concentration, there are 7 concentration terms, right? One is mass percentage, volume percentage, mass by volume, ppm, mole fraction, molarity and molality. So out of the 7, we have covered 5 concentration terms yesterday. Okay. So today we are going to see molarity and molality. So after completing this, we can move on with the next topic. Okay. So coming to molarity. So what is molarity? And it is denoted by the letter capital M. Okay. It is denoted by capital M. And coming to the definition of molarity, it is the number of moles of solute dissolved in 1 liter of a solution. The molarity concentration term is very, very important, and it is the number of moles of solute dissolved in 1 liter of the solution. If I want to denote this mathematically in a formula form, then I have to write M is equal to number of moles of solute divided by volume of solution in liter. Okay, number of mole N by V is nothing but the concentration. So this is very, very important. This formula is very important, which you will be using in most of the physical chemistry lessons. Okay. Now what is the unit? So in numerator we have number of moles, and in denominator we have volume in liter. So what could be the unit of molarity? It is mole per liter. The unit of molarity is mole per liter. Okay, you should not forget. Then coming to, so have you all noted this formula and the definition in your notebook? Shall I move on to the next slide? Yes? Yes or no, students? Shall I go with, proceed with the next slide? Okay, thank you, Jyoti Lakshmi. Now coming to the next slide. Now with increase in temperature, molarity decreases. So with increase in temperature, molarity decreases. Means molarity is dependent on temperature. Okay, so molarity is inversely proportional to temperature. So if temperature increases, molarity decreases. In the other way around, what we can say? If temperature decreases, molarity increases. So they are inversely proportional to each other. So this is very, very important. So molarity is dependent. They depend on temperature. So write this and keep this in your notebook. Molarity is the concentration term which depends on temperature. Okay. Now moving on to the next thing. Question. So we are going to see one question based on this molarity formula and the concept. Okay. So calculate the molarity of a solution containing 5 gram of sodium hydroxide in 450 ml solution. So what we have to do? We have to find out the molarity. So what is given in the question? So we have 5 gram of NaOH. So NaOH is the solute, okay? And 5 gram is the mass of this solute. 5 gram is the mass of the solute. And in 450 ml solution, ml means it is volume. The volume is given in terms of milliliter. Okay. Now coming to the problem. So to find out the molarity, what we need? We need the number of moles of solute divided by volume of solution in liter we need. Okay. So number of moles is not given in the question. Now how to find out the number of moles? Yesterday I have given one formula, right? So number of moles is equal to the given mass divided by molar mass. Okay, what is the given mass? Mass is 5 gram, and the molar mass of NaOH we have to calculate. For sodium, the atomic mass is 23, and for oxygen, the atomic mass is 16, and for hydrogen, the atomic mass is 1. So if you add all these three values, what you will get? You'll get 40, no? So the 40 is the molar mass of NaOH. Okay, so what is the number of moles? It is 1 by 8. Okay, 1 by 8 is the number of moles. So moles of NaOH is equal to 5 divided by 40 gram per mole. Okay, which is equal to 1 by 8, or it can be 0.125 mole. So we have found out this number of moles. Now what else we need? We need the volume of solution in liter. But in the question, the volume is given in terms of milliliter. So convert this milliliter to liter. Convert this milliliter to liter. So for that, what you need to do? You have to multiply the given milliliter into 1000. Okay. Divided by 1000 ml. So what you will get? 1000 ml is nothing but 1 liter. So yeah, milliliter gets cancelled here. Then we will get 0.45 liter as the value for volume. Okay. Now substitute these two values in the formula. So the formula is using the given equation, molarity is equal to number of moles by volume, which is equal to 0.125 divided by, what is the volume value? 0.45. Okay. So if you divide these two, what you will get? Has anyone got the answer? Has anyone got the answer here? What is the value you are getting by dividing these two numbers? Find out fast and let me know the answer with at least two decimal, two digit after this decimal, two digit after this decimal. What is the value you are getting, students? So some of you have got 0.27. Very good, very good. So the answer is 0.278 molar. Okay. So this is the molarity value for the given question. Good. So shall we move on to one more question? Have you all taken this down in your notebook? Shall we move on to the second question? Yes. Do you have any doubts from the molarity part? Now you can able to understand how to apply the given values in the question, right? Yes or no? So if you're having any doubts, just let me know in the chat box. Okay, I will repeat. Now let's move on to the next question. Calculate the molarity of 20 percentage mass by mass. Okay, sodium hydroxide solution. And the density of the solution is 1.2 gram per centimeter cube. So density is given. Concentration is also given in terms of mass by mass term, and we have to find out the molarity. So how to find out? Again, we need to find out the number of moles of the solute. Okay. So for finding out the number of moles, we need mass by molar mass. Again, the compound is sodium hydroxide. Compound is sodium hydroxide. So the molar mass of sodium hydroxide will be 40. Okay. The molar mass will be 40 and we have to find out the mass. Now, what is the mass value? What is the meaning of this 20 percentage W by W NaOH solution? Yesterday we have studied, right, in mass percentage. 20 percentage W by W means 20 gram sodium hydroxide is present in 100 gram of the solution. So this is the meaning. Okay. So how many gram? 20 gram is present in 100 gram of the solution. So the mass of sodium hydroxide is now equal to 20. It is equal to 20. So 20 by 40 is nothing but 1 by 2. Okay, it is 1 by 2 and you can keep this as 20 by 40 itself, no issues. Okay, so number of moles is ready. Number of moles is ready to substitute in the molarity formula. What else we need? We need volume of solution in liter. So what? No information is given about the volume. Okay, but density is given. So from the given density value, we have to find out the volume. How to get that? We know that density is equal to mass by volume. So from this formula, what is volume? Volume is equal to mass by density. Okay. So what is the given mass? What is the mass? It is 100 gram. Okay. 100 gram is the mass of the solution. And divided by the density of the solution is 1.2 gram per centimeter cube. Okay. If we divide these two, volume is 8.33. Okay. Okay, very good. Very good. So volume of the solution is now given in terms of milliliter here. But we have to convert this into liter, right? So what do we need to do? So divide by the number 1000. To convert milliliter to liter, divide by the number 1000. So this is the volume. And the number of moles is there, volume is there. What we have to do? Substitute in the molarity formula. Okay. So molarity is equal to number of moles of solute, which is nothing but 20 by 40 divided by volume of solution in liter. It is 100 divided by 1.2 into 1000. Okay. So just do this. And if we do the calculation here, what will be the answer we will get? So 0 gets cancelled here. And it is 0.5 divided by 20 into 1.2 into 1000 divided by 40 to 100 we will get. So it will be around, what is the molarity value? Has anyone got the answer? Has anyone got the answer? 20 into 1.2 will be there. And here we will have 10 divided by 40. So again 0 will get cancelled here. So 1 by 2. So here 5. So 5 into 1.2 is 1.2 into 5 we are getting, no. So molarity is equal to 6 molar. So the answer is coming out to be 6 molar. So one of you have got the answer, I think. Very good, Aju. Very good. Answer is 6 molar. It is the correct answer. Okay. So let me show you the solution in the next slide in a clear way. Okay. So 20 percentage means 20 gram of NaOH is present in 100 gram of the solution. So from the given density value, we are getting the volume, okay, in terms of liter. Then number of moles is also calculated using mass by molar mass. And these two values are substituted here in the formula. And finally, we are getting the molarity. Okay. Is this problem clear to all of you? Is this question clear to all of you? I hope it is clear. So let me move on to the next question. So the next question is, what is the molarity of 5.30 gram of sodium carbonate dissolved in 400 ml solution? Molar mass of sodium carbonate is given as 105.9 gram per mole. So can anyone try the answer for this? Can anyone try the answer? So I will give you guys how many minutes are needed? I'll give you 2 minutes. I'll give 2 minutes to solve this question. So try to get the answer within 2 minutes. If it exceeds 2 minutes, then we can discuss in the class. Okay. So give a try. First of all, give me the answer for number of moles. Find out the number of moles first and give me the answer. Number of moles is equal to mass by molar mass, right? So mass is also given, molar mass is also given in the question. So find out the answer and give me the answer. Number of moles is equal to mass divided by molar mass. So the given mass of sodium carbonate is 5.30 divided by the molar mass of sodium carbonate is 105.9. So has anyone got the answer? By dividing these two numbers for number of moles? Yeah. Yes, JNB Nagar has got the answer. What is the value for number of moles you got, students? Very good, very good. It is 0.05. Yeah. So 0.05 and we will be having 0.04. We can use these values or we can leave this also. Okay. So let me keep this as 0.24. No, it is 0.005004. Okay, so this is the value. Now, number of moles is calculated and volume is given in the question, but in terms of milliliter. So we can convert that into liter by dividing by the number 1000. Okay, straight away I'll go to the formula. So molarity is equal to number of moles by volume in liter. So the number of mole is 0.05004. Okay, divided by volume of the solution is 400 divided by 1000, and that 1000 will go to the numerator. Denominator of the denominator goes to the numerator. Okay, so we can cancel this, and 2 and 5. Okay, can cancel the value like this, and the final answer is, has anyone got the final answer? Has anyone got the final answer? Okay, very good, Vijay, very good. So the answer is 0.125 molar. Molarity is 0.125 molar. Good. So the clear explanation is here to you on the screen. If anybody want to note this down, you can note down. So now I hope you will be able to solve questions from molarity, right? So shall we move on to the next topic? Yes. So the next topic is molality. So molality is the seventh concentration term, which is the last concentration term. Okay, so let's study about it. Molality. Molality is denoted with small m. Molarity is denoted with capital M, and here it is small m. And the definition for molality is the number of moles of solute present in 1 kilogram of the solvent. 1 kilogram is nothing but 1000 grams. So we can say number of moles of solute present in 1 kilogram or 1000 gram of the solvent. Okay. So the formula will be number of moles of solute divided by mass of the solvent in kilogram. So the numerator remains same for both molality and molarity. Okay. So in the numerator we have the same thing only. But only in the denominator here we have mass of solvent in kilogram, and there we had volume of solution in liter. Okay, this is the only change you have to note down. Now here in the numerator we have the number of moles. Okay, so the unit for number of moles is, mole is nothing but moles. And here the unit is, for mass it is kilogram, right? So the unit of molality is mole per kg. It is mole per kg. Okay, so this is the unit of molality. Now next, coming to the some of the informations about molality. So unlike molality is independent on temperature. Very important to note down. Okay, molality is independent on temperature because the mass does not change with temperature. So in the molality formula, we are getting number of moles in the numerator and mass of the solvent in the denominator. No, so mass does not change. Mass of the substance does not change if we change the temperature, right? So the molality will also remain same. So molality is independent on temperature, but molarity is dependent on temperature. Okay. So since this molality is independent of temperature, it is the most and common and convenient method to express the concentration of the solution. Okay, so among the 7 concentration term, the most convenient method or the way to express the concentration of a solution is in terms of molality. Okay, so just take down these 2 points first, then we will move on to the next thing. Okay, I'll go with a question from molality. So here is a question to you. Calculate the molality of 2.5 gram of ethanoic acid in 75 gram of benzene. How to approach this question? So we have 2.5 grams. So this is the mass of the solute. Okay. And 75 gram of benzene. Benzene is a liquid, no? So it is a solvent. Benzene is a solvent. So this is the mass of solvent, and this is the mass of solute. Okay. So two informations are given to us and the formula of the compound is also given to us. Now we need to find out the molality. So it is equal to number of moles of solute divided by mass of the solvent in kilogram. Okay, mass of the solvent in kilogram. So now to find out the number of moles, the formula is mass divided by molar mass. So the mass is given. So it is 2.5 gram. Molar mass of acetic acid we need to calculate. The molecular weight of the C2H4 and O2, ethanoic acid or acetic acid has to be calculated. For carbon, what is the atomic mass of carbon? 12, right? For one carbon, the atomic mass is 12. And we have two carbon in the formula. So it is 24. And for each hydrogen, it is 1. We have 4 hydrogens. So it is 4 into 1. Sorry, 4 into 1, 4. And we have 2 oxygen. For each oxygen, the atomic mass is 16. And for 2 oxygen, it will be 32. So now if we add all these things, we will get 60. So 60 is the molecular weight of this 0.44. Okay, very good, very good. So 2.5 divided by 60 is the number of moles. Okay, weight of ethanoic acid is 2.5 gram. Weight of the solvent is 75 gram. Now molality is equal to weight of the solute or mass of the solute so divided by molecular weight of the solute into 1000 divided by weight of the solvent. This part is nothing but the number of moles. Okay, number of moles divided by mass of the solvent in kilogram. If I'm giving in terms of gram, then I have to divide by the number 1000. That 1000 is going to the numerator. Okay, this is the another formula. Straight away you can substitute the values here. So here we have got 2.5 divided by 60 into 1000 divided by 75. Okay, and if we solve this, we will get. So who has given me the answer 0.44? Yeah, Vijay, you have done a very minute mistake over there. It is 0.556. Very good, very good. Oh, Vijay have changed. Okay, okay. Okay, good, good, good. So the answer is 0.556 molal. Okay, you have to return the value, write the value in terms of molality. So we have to put a small m. Okay, 0.556 molar. Good. Now moving on to the next question. Yeah, no question. So with this, the concept is getting over. Now the next topic is solubility. Okay, so 7 concentration terms are getting over here. So 7 formulas you are going to study from the 7 terms, and each and every formula is very, very important. Among these 7 formula, mole fraction, molarity and molality formula is very, 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 very important. Okay, so do any of you guys have any doubt from the concentration terms topic that we have discussed yesterday and today? Shall I go with the next solubility topic? Yes, yes, or no? If you're having any doubt, you can ask me now from the classification and from the concentration terms. If everything is clear, just give me a thumbs up or type, ma'am, it is clear or something so that I can understand you have understood. Okay. Yes. Thank you. Thank you so much, Ajo. So now let's move on to solubility. What is solubility? Any idea? Do any of you guys have? What is solubility? What is the definition for solubility? Okay. Solubility of a substance is its required amount of solute that can be dissolved in a specified amount of solvent. The amount of solute that can be dissolved in a specified amount of solvent to make a saturated solution at a specified temperature and pressure. Okay, so some amount of the solute is taken and it is dissolved in a specified amount of solvent, and that we call as solubility. Okay, now the solubility depends upon 4 factors. One is nature of solute. The next one is nature of solvent. Third is temperature. Fourth one is pressure. Okay. So these are the factors affecting solubility. Okay. Now let us discuss the effect of these factors on solutions of a solid in a liquid type. So first I am going to take solid in a liquid, then we will discuss about gas in a liquid. Okay, first let me take solid in a liquid type and then we will discuss the effect of these four factors on that. Okay. Now coming to solubility of solid in a liquid. Now let's see how the nature of solute and solvent is going to affect. So polar solute dissolves in polar solvent and non-polar solute dissolves in non-polar solvent. So simply to say, like dissolves like dissolves like. Okay, polar dissolves in polar, non-polar dissolves in non-polar solvent. Okay, so like dissolves like. For example, if I go for the first case, polar solute. Polar solute means NaCl can be taken as an example. Sodium chloride is a solute in which positive and negative ions are there. It is a polar component. Okay. So sodium chloride can be dissolved in polar solvent only. So who is a polar solvent? Water is a polar solvent, right? Because in water we have H plus and OH minus. So both of them are polar. NaCl is also polar, H2 is also polar. So sodium chloride is getting dissolved in a universal solvent, water. Okay. Now coming to non-polar. Non-polar solute in the sense we can take some benzene kind of thing. Okay. Some hydrocarbons with carbon number greater than 18. So those components you can take. We can take wax. Okay. Paraffin wax we can take. Wax is also a hydrocarbon with more than 20 carbon atoms. Okay. So it is a solid, non-polar solid because only carbon and hydrogens are present there. So it is a non-polar component or non-polar solute. So it can be dissolved in non-polar solvent. The example for non-polar solvent is benzene. So benzene also contains hydrogen and carbon, which is non-polar in nature. Okay. So polar dissolves in polar, non-polar dissolves in non-polar. Okay. So the solubility of a solid in a liquid is affected by the nature of the solute and solvent. Okay. A polar solute cannot be dissolved in a non-polar solvent. The other way around is not possible. Got it? Clear? Shall I move on to the effect of temperature? The third point? Yes. So coming to the effect of temperature, the solubility of a solid in a liquid is affected by temperature. So how it is going to affect? So the change which we are going to give here is denoted by the letter delta H of the solution, which is nothing but change in enthalpy of the solution. Enthalpy change in solution is denoted as delta H solution. Okay. If the dissolution process is endothermic, the solubility should increase with increase in temperature. So what is meant by endothermic? Heat energy, if it is getting absorbed, we call that process as endothermic. For endothermic process, delta H is greater than 0 means delta H is positive. Greater than 0 means it is positive. Means the solubility should increase. Solubility is increasing with increase in the temperature. Okay. Then if the dissolution process is exothermic, then delta H is less than 0. Delta H value is negative and the solubility should decrease with increase in temperature. Solubility is decreasing with increase in or with rise in temperature. Okay. So these 2 points are very, very important to note down under the solid and liquid topic. Okay. About solubility. So take down these two things. So this is in the form of statement and here it is a gist of the statement. So exothermic means energy will be released. Heat energy is released process. Energy releasing process. Okay. So have you guys taken this down? Shall I go with the next slide? You don't have to write the whole statement, just write the short forms which I have written on the screen. Okay? For endothermic, delta H is positive. So solubility increases with increase in temperature. And in the other case, it decreases with increase in temperature. Okay, fine. Shall I move on to the next thing? Yes or no? Give me your answer in the chat box. Shall I go with the effect of pressure for solid in a liquid form? What is delta H solution? Yeah, change in enthalpy value. So in class 11, you might have come across with the thermodynamics lesson, right? So in thermodynamics lesson, we would have come across with this term delta H. Delta H. Okay. So delta H. So change in the energy value. So after giving the temperature and before giving the temperature. So the change is taken and that is denoted as delta H of the solution. It cannot be equal to 0. It can either be positive or it can be negative. Okay. For endothermic and exothermic process. So only for ideal solutions, delta H will be equal to 0. Okay. All the solutions which we are discussing here are non-ideal only. So when I will be discussing the ideal and non-ideal solutions after completing this topic. In that time, you can understand this in a better way. Okay. So ideal solutions will have delta H 0 where the change in enthalpy value will be 0. Means the initial and final point will be same. In that case only the change will be 0. Okay. That is applicable for ideal solution. But all these things are for non-ideal solution. Is that okay, Vijay? Vijay FCSA. Is that okay? Shall we move on to the effect of pressure? Yes. Okay, my dear. So the next is effect of pressure. So we have discussed the nature of solute, nature of solvent, and the effect of temperature. Now, oh, you are from JNVNM. Okay, okay. So the name is your Vijay FCSA. So I thought it is you are a single student. Okay, okay, JNVNM students. Good. So coming to the fourth factor, effect of pressure. Pressure does not have any significant effect on solubility of solid and liquid. It does not have any effect. Okay, because if I am having a liquid in a container and if I add a solid here in this container, okay, this is a solid substance. And if I try to give pressure here, will there be any change? If I am giving the pressure on a solid in a liquid? No, right? It is not going to change. It remains same only. So this is because solid and liquid are less compressible compared to gases. So if I am giving pressure on a gas, then the solubility will increase. Okay. But a solid and liquid, if you take, since they are very less compressible, even after applying the pressure to that solid, it is not, the solubility is not going to change. It is not going to increase. Okay. So pressure has no effect on solid in a liquid case. Clear? Fine. Shall we go with the next thing? Yes, I will move on to the next type. Now, next we are going to discuss the types of solutions based on solubility. Okay. So now we have discussed solid and liquid type and we have discussed the four factors which affects the solubility for this case. And now we are going to discuss the types of solutions based on solubility. So we have solutions are classified into saturated solution, unsaturated solution and supersaturated solution. Okay. What is meant by saturated solution? A solution in which no more amount of solute can be dissolved at the same temperature and pressure. No more amount of solute can be dissolved at the same temperature and pressure is called as saturated. Okay, means we have a container and we have a solution inside that. Okay, solvent and the solute which has formed the solution, and no more amount of solute cannot be added. Should be added. Okay, means the solution has already attained the saturated point. Okay, there is no use in adding more amount of solute into that container. Okay, means that particular solution is called a saturated solution. So there exists an equilibrium between the dissolved solute molecules and undissolved solute molecules in the solution. So we have a container. Already we have a solvent there and we have added a solute, and now they have got dissolved. This is the dissolved solute molecule. Dissolved solute molecule. Now if I still add some solute particles here, they will not get dissolved. Okay. So it means that solution is called a saturated solution. So solute plus solvent is now going to be in equilibrium with the solution. Clear? Now the next thing is unsaturated solution. So what is meant by unsaturated? A solution in which more amount of solute can be dissolved at the same temperature and pressure. More amount of solute. So still you can add some more amount of solute into the container. Means that solution is unsaturated. So the amount of solute present inside the container is very less than that in the saturated solution. Okay. So since the amount is very less, we are adding more amount of the solute. That's all. Now coming to supersaturated solution, a solution in which there is more amount of solute than that is present in a saturated solution at the same temperature and pressure. So already we have some solution, and if I still add some more amount of solute into that, okay, so it will get dissolved. Then that is called a supersaturated solution. So the solvent holds more solute than is normally possible at that temperature. Okay, so solvent will hold more amount of solute particles in case of supersaturated solution. So let me show you these three in a single picture in the next slide. So on the basis of saturation, it is classified into three: unsaturated, saturated, supersaturated. In the middle, you can see in saturated solution, you cannot add solute. No more solute can get dissolved. And in case of unsaturated, more solute can be dissolved. So we are adding some more solutes here and that can get dissolved here. And in case of supersaturated solution, it becomes unstable. So on addition of more amount of solute to this, so they cannot get dissolved. Instead of that, they form a crystals like this. Okay, so they are called as supersaturated solution. So is this clear to all of you guys? Do any of you have any doubt from the types of solutions based on saturation? Shall we go with the next slide? Yes or no? If you are taking it down, just let me know. I will wait for you guys. Yes. Thank you. Thank you, ENM students. So the next topic is solubility of gas in a liquid. Solubility of gas in a liquid. So far we have discussed about solid and liquid. Now we are going to discuss about gas and liquid. So coming to this topic, so HCl gas, hydrogen chloride gas, ammonia gas, sulfur dioxide gas. So these gases are highly soluble in water basically. Okay. So the easily liquefiable gases are more soluble. The gas which can get liquefy easily, so they are more soluble also. So liquefiability is directly proportional to solubility. So it is greatly affected by pressure and temperature. Solubility of gases is greatly affected by pressure and temperature, and now let's see how they are going to affect. So coming to the effect of pressure first. Solubility of gases increases with increase in pressure. Okay, suppose I am taking a container and I am putting solvent molecules and solute particles over there. Solute is nothing but the gas here. Okay, so I'm putting gases inside that container. And if I give pressure using a piston, piston is the instrument which is used to apply pressure. If I increase the pressure of the system, the solubility will increase. Okay, if I increase the pressure of a gas, solubility will increase. Okay, very important point to know about the solubility of gas in a liquid. Clear? Now next coming to Henry's law. So Henry's law is based on this gas and liquid concept only. Now what is Henry's law? It is the partial pressure of the gas in vapor phase. Vapor phase is directly proportional to the mole fraction. Partial pressure is directly proportional to mole fraction. So mathematically, Henry's law is expressed as P is equal to Kh into X, where P is the partial pressure of the gas and X is the mole fraction, and Kh is the Henry's constant. Henry's law constant. So partial pressure is directly proportional to mole fraction. So if one increases, the other one will also increase. So let us see a graph. So Henry's law is very important for your school exam as well as for NEET exam. Okay. So you will get numericals based on this formula. Clear? And also one more relation I'll give you. KH is inversely proportional to solubility. So take down this relation and you will understand the importance of this relation while solving the questions from Henry's law concept. Okay. So KH is inversely proportional to solubility. Now coming to the graph. Coming to the graph. So here this graph is between partial pressure and mole fraction. So partial pressure is taken in y-axis and mole fraction is taken in x-axis. So we are getting a straight line here because they are directly proportional. So as the mole fraction increases, partial pressure also increases. Okay. So straight line with a positive slope is observed for this relation, Henry's law. Okay. Now, I would like to ask you one question. So in soft drinks and soda water, if you take carbon dioxide is passed under high pressure and they are sealing that container, no? So why they are doing like that? If you take some soda or some soft drinks, so the gas which is present inside that is carbon dioxide. So after passing this gas under high pressure and on and they are sealing it. Why? Very good. Very good. To increase the solubility of carbon dioxide based on Henry's law. So if you increase the pressure of the gas, the solubility will increase. Okay. You can see the soft drinks here. And one more question. The scuba divers have high concentration of dissolved atmospheric gases in blood. Why? Scuba diving, you know, right? So to avoid, it is not bends, it is bends, BNDS. Okay, very good. So scuba divers, they go deep into the sea first of all. Okay, so because of that, it will result in high pressure underwater. So that pressure causes more solubility because high pressure means more solubility, right? So high pressure underwater increases the solubility of gases. Okay, inhaled based on Henry's law. So scuba divers go deep into the sea because solubility increases there. And here you can see, yeah, one more question is also there. After completing this question, we can come to the picture. So when scuba diver come to surface, they experience a medical condition known as bends, which are painful and dangerous to life, right? So why is it so? When divers come to the surface, pressure decreases. Okay, you can see it in the picture. When they are underwater, pressure is more, the solubility of the gas in blood is also more. Now, when they come to the surface, what happens? The pressure is decreasing on the surface. Okay. So, this releases the dissolved gases and leads to the formation of bubbles of nitrogen in the blood. So, they form a nitrogen bubbles in the blood and those bubbles will block all the capillaries in the blood and they create a condition called bends. Okay. So inside the water, solubility increases because pressure is more. And on the surface of the water, solubility decreases because the pressure is very less. Okay. When the pressure becomes or when pressure decreases, the bubble like nitrogen is forming in the blood and it is blocking the capillary and creating a condition called bends, which is not good. Okay. And that bends only causes pain. Okay. And it is very dangerous to life also because it is blocking, no, blocking the capillaries, right? So it is dangerous to life. Got it. So here the concept is getting over. I would like to close the today's session with one numerical based on Henry's law. Okay. So here is the question to you guys. So find out the answer fast. So if you are getting the answer first, we can wind up the today's session. So Henry's law constant for the molality of methane in benzene and 298 Kelvin is given. Henry's law constant means what is this? KH is given in the question. Calculate the solubility of methane in benzene at 298 Kelvin under 760 mm mercury. What is the 760 mm mercury? It is the partial pressure. So pressure is given, Henry's constant is given. According to Henry's law, partial pressure is equal to Kh into mole fraction. So we don't know what is, we have to find out this mole fraction. So mole fraction is equal to partial pressure divided by Kh. Okay. So what is partial pressure? It is 760 mm mercury divided by 4.27 into 10 to the power 5. So it will be equal to 177.99 into 10 to the power minus 5. Okay. So this is the mole fraction of methane in benzene. Okay. X is nothing but the mole fraction. Mole fraction of methane in benzene, which is nothing but the solubility. Okay. So here is the detailed clear explanation for you. The mole fraction of methane in benzene is 177.99 into 10 to the power minus 5. Okay. So here it ends. So thank you so much for listening to today's lecture. So if you're having any doubts, you can ask me now. So otherwise, we can meet up in the next session. Yeah, JNVRM students, tell me. Thank you so much. Same to you. Happy Ugadi. Thank you. Thank you, dear students. Thank you so much for listening to today's lecture. To meet you all in the next session. Okay. So take care. Bye bye.